Hello, everyone. We're going to look again today at the transformation of energy from gravitational potential energy into kinetic energy. This time we're looking at a pendulum. I created a pendulum by using a softball that I drilled a hole through and tied a rope to, and I tied it to the top of my basket right up here. And when I start the video, I'm going to be holding that softball in my hand over on the left-hand side. So I was holding that softball up to my chin and I released it directly from underneath my chin. I'll rewind it just a little bit so you can see that. Now we know that the law of conservation of energy tells us that energy cannot be created or destroyed. So the amount of energy, potential energy in it at this point is going to be conserved throughout this entire system. Now, I stood here without moving, knowing that that pendulum's not going to reach up back to my chin and hit me in the face. That's because really energy isn't entirely staying in the system that you see with just the pendulum swinging back and forth. It's going to come in contact with the air around it, causing drag. There's going to be friction between the pendulum and the pivot point right here at the top of my basket. That's going to transfer some of that energy out of the system. For the purpose of our activity today, we're going to ignore drag and friction. So technically, the amount of energy at the beginning as it swings should be conserved all the way back up to this original swing, even though it doesn't hit my face, or as you can see, it doesn't come close to hitting my face. So once again, the ball, the weight of the pendulum, is at its highest point right now. Now I'm going to release it and I'm going to stop this video when it's about halfway down on its downswing. I'm going to stop it again when it's at its lowest position down here. We'll stop it again as it's halfway up on its upswing, then at the peak of its upswing over on the right. So I'm going to show you just the video through one time. Then we'll go back and pause at those locations and talk about the unique properties of energy at each of those locations. So that's one complete oscillation or one complete swing. And you can see where I caught it. It's a lot lower than where my chin originally was. We're ignoring drag and friction, and it should have reached up to my chin if there wasn't drag or friction. But we'll talk more about that later as we learn more about physics. So for now, let's go back to its original position. This is at its highest elevation. So that should tell us about the amount of gravitational energy at this point. And also, the ball is not moving. So if the ball is not moving, that should tell us a lot about the kinetic energy at this point. Once I release that ball, some of that potential energy becomes kinetic energy, and the ball begins to move. As it's moving downward, I'm going to call this position about halfway down on its downswing. You have to think about right down here is going to be its lowest point. This is about halfway in between. So with the total height starting at my chin being 100% gravitational energy, when it's halfway down on its swing, you have to think about what kind of percentage of energy is halfway down. As it continues to swing and it goes to this lowest position, we're going to call this position number 3. All of that gravitational potential energy, it has no height. It has no elevation anymore. So it's going to tell you something about that gravitational potential energy. If it has no height, it has no elevation, that should tell you a lot about what our number should be for kinetic energy. If it's no longer potential energy, it must be energy of motion. That's kinetic energy at this lowest position. Now, things are going to go a little bit in reverse on that upswing. As it begins to travel upward, we're going to call this halfway up on its total swing up the other side. We are gaining back elevation. So that's transforming our kinetic energy back into gravitational, but it's not at its highest point yet. And as it continues its upswing to the right side, we'll see if my son, the cameraman, was able to capture this. And yes, he did. There it is at its highest point on the right side, where there's going to be a fractional moment in time where it's no longer swinging upward and it hasn't started its swing downward. There may be a fraction of a second where it's not moving up and it's not moving down yet either. That should tell you a lot about its kinetic energy. If it's not moving, can it have kinetic energy? Then it's going to start that cycle back again the other way. But for our purposes today, we're just considering one entire swing to the right. Okay, we could get into more about the cycle or oscillations of going back and forth later. But for the purposes of our activity today, let's concentrate just on one swing, starting on the left and ending at this position all the way to the right.